Hi everybody, I'm Chunghan from Fujisu. Today I present understanding storage traffic characteristics on enterprise VDI. As a first step, I'd like to introduce VDI. VDI consists of virtual VMs and remote storage and network fabric and connection broker and finally their client. And it has several main advantages of VDI. And it can enhance security and reduce management cost. Moreover, currently it has been used in real-world office and universities. Next, I'd like to introduce the previous storage measurement study. Unfortunately, previous measurement study have focused on the SIS and storage traffic in personal cloud storages. However, there is only one field study with small-scale VDI, and they analyzed the storage traffic characteristics on the VDI by collecting traces from hypervisor only. Here is our research goal. Our research goal is a deep understanding of storage traffic characteristics with large-scale VDI. In order to achieve our research goal, our approach is as follows. We actually focused on the two perspectives, FC traffic and VM behavior. And firstly, we gathered actual data from a part of enterprise VDI for 4 weeks. And this data set consists of various traces, active and passive measurement, and user questionnaire. And finally, we analyzed this data set corresponding to approximately 18 TB of storage traffic on approximately 300 VMs. This table indicated our key finding. However, there is no time introduced all of them. Please refer to our detailed contribution in the paper. And in this presentation, we mainly focused on the key findings 3, 4, and 6. Next, I'd like to present our target VDI. As I mentioned before, target VDI is a part of Office VDI. It consists of 6 physical servers and 6 block storage with FUИ fabric. And it provided a designated VM, Windows VM to each user, like this figure. And it also provided pre-installed software such as Microsoft Office and antivirus software. And in particular, the user can install their desired application and save their data anytime. It's a different point of the pool-based VDI. Next, there are 3 constraints to measure target VDI. I'd like to introduce how to overcome these constraints. The first constraint is we cannot install the monitoring component on a VM or hypervisor. It's a real product VDI. We cannot estimate how to affect the monitoring system to entire VDI. Our approach is that we capture the FC traffic and gather the performance metrics from storage and VDI servers. And second constraint is that the VMs are already running to reduce the impact of time-consuming operation such as VM restart. Our approach is that we gather the connection broker logs from VDI portal to distinguish active VM. Active VM is connected to users currently. The last constraint is that we cannot log on to user VMs, and it is hard to inspect the user application on the VM. In order to overcome this constraint, we gathered a list of applications at all VM and distributed usage questionnaire to determine which application is actually run. Yes, please look at this figure. This figure indicated target VDI with measurement system. We gathered various datasets from VDI monitoring system and FUïTSU catcher and connection brokers. And here is a list of our dataset for analysis. The dataset consists of FUïTSU trace for 4 weeks and connection broker logs and the Windows performance counter and storage performance statistics and other offline data. Before presenting our analysis result, I'd like to introduce the applications installed on the VM. Please look at this tree map. In the tree map, deeper colors and larger rectangles indicated the large proportions. In order to create a tree map, we manually and empirically classified the applications into 9 categories, and we found that pre-installed software OPs and antivirus software had a large proportion. These applications were similar to the small-scale VDI. Next, from now on, I'd like to introduce our analysis result. Please look at these graphs. In these graphs, the x-axis is hours, and y-axis is VM IDs, and y-axis is MB per second throughput. In these graphs, there is burst read traffic like this, and in the result, read traffic is dominant. Moreover, in the morning, 9 a.m., the massive traffic is generated like this result. Our summary is that the VM level traffic widely fluctuated and depend on both time and VM levels. Moreover, it would be possible to exist heavy VM. From the analysis result, there are 3 questions. The first one is what happened in the morning. The second one is why read traffic is dominant. The last one is how the heavy VMs are affected to entire VDI system. From now on, I'd like to answer these questions through our analysis result. First, I'd like to introduce what happened in the morning. Please look at this graph. In this graph, x-axis is day and y-axis is throughput. This result indicated write throughput. And in the result, the spike in the morning is observed like this. From application logs, we found the regular update of antivirus. The update was simultaneously executed by hundreds of VMs, and it acted on update storm. During the storm, the large throughput was achieved, and the response time largely increased. Next, I'd like to present the characteristics of the update storm. The storage response time was largely degraded from 20 milliseconds during the storm. The 20 millisecond is recommended response time by VML, just reference data. Please look at this graph. This graph indicated the CDF of the write response time. We pick up 3 times morning, lunchtime, and ordinarily afternoon. In the morning, the red color, the CDF shape is different from the other time beings. Thus, the response time of 20 milliseconds is slow in the morning. Next, I'd like to introduce this result. This result indicates right size distribution. In the morning, the large right sizes such as 1 to 8 kibibyte has a large proportion. It's approximately 50% of the right size. Next, please look at these graphs. In these graphs, the x-axis is time, and the updated storm is occurred actually this time. The above graph indicated cache hit rate, and the below graph shows the response time. Even when the right cache hit rate is slightly decreased, the response time of the large size of transaction is greatly affected. Digit size is affected to the slightly decreased cache hit rate. And as a result, on the regular right cache memory, the large size transactions are much more affected than the small sizes. From our analysis result, our implication is that the transaction size for right cache hit should be considered to improve the entire VDI performance. Next, I'd like to talk about the major cause of dominant read traffic. Please look at these graphs. In these graphs, x-axis is time and y-axis is bytes. In the morning, as I mentioned, there was an updated storm. We separated 2 types of traffic from idle VMs and active VMs. The black color indicated idle VMs. The idle VMs account for approximately 76% of the total traffic. The antivirus software and Windows service, such as the daemon process, were major applications to generate large read traffic. Oppositely, the active VM connected to user issued only about 24% of total traffic. Our implication is that traffic from the active VMs should be more considered to shorten their response time. Next, I'd like to introduce traffic distribution across VMs. Please look at this graph. In this graph, x-axis is hour and y-axis is Gini coefficient. Gini coefficient shows how to balance the data set. In our case, the low Gini coefficient, the traffic distribution is homogeneous. Thus, the VM generated a similar traffic distribution. However, the large Gini coefficient is oppositely traffic distribution is heterogeneous at all VMs. Please look at the morning. In the morning, traffic distribution is almost homogeneous. In our case, the major cause of homogeneous traffic is update storm. oppositely, please look at in the launch time. And at the launch time, the read bytes has the largest Gini coefficient, and this means that traffic distribution is heterogeneous. The major cause of the heterogeneous is scheduled virus scan by some VMs. Moreover, please look at this graph. In this graph, indicated Lorentz curve of the read byte. As I mentioned, the read byte has the largest Gini coefficient. And the red color indicated in the morning, and the green color indicated lunch time. And the lunch time had the largest Gini coefficient, and we calculated only 1% of the we calculated 1% of active VM. They generated traffic amount. The result is that the 1% of active VM only generated approximately 70% of traffic. This value is very small previous cloud storage. Some cloud storage generated 1% active users generated 60% of the traffic. We imply that the impact of a heavy VM is small, and special load balancing strategy is not needed to office VDI system. Next, I'd like to conclude our analysis result. First, there was an updated storm of antivirus software. Our implication is that transaction size should be considered to improve the entire VDI system. Second is that there was heavy read traffic from either VMs. We imply that traffic from active VMs should be more highly considered to shorten their response time. The last one is that the impact of heavy VMs is small, and 1% of active VM generating only approximately 70% of traffic. There is no requirement of the special load balancing strategy. Here is a list of our feature work. The first one is to analyze the characteristic of user application workload on the active VMs. And the second one is to investigate the storage traffic characteristic on the different types of VDI system, such as the pool-based VDI. That's all. Thank you for listening.
Any questions? Yes?
So, I think your work is really interesting. Just a small point. Isn't sort of the obvious thing about the update storm, is it not just to move the time of update to a time when active VMs are not active, like at night? Is that not sort of the obvious conclusion there? So, for example, you mentioned in your work that the updates, the majority of them, are happening at 9 a.m., which coincides with when users are actively using VMs. There are technical solutions to this problem, but isn't the more complete and obvious solution to just move that update time?
Yes, yes,
2 in the morning?
yes. We distributed the updated at the time of updated. Also, we applied then, and the updated storm was disappeared in the system. in currently, yes.
Did you see any evidence for saturating the storage?
Saturating storage?
Yeah, because you have a big write, a big update storm, and then a big scan. And it looks to me like the storage system is handling the load, right? The storage itself. Like not too much bandwidth. It's okay, no problem. At least I look at it looks like there's a peak, but it's not clipped. So the storage is perhaps too strong here.
Maybe like this. It's the spatial distribution at the storage like this, and in the morning, many write is accessed all of storage, and storage is overheaded, and without active and idle VM, all of VMs is slowed down.
So you later conclude
Yes.
from this data
Yes.
that you don't need special load balance.
Yes.
So what you could instead
No.
perhaps think is use a cheaper storage and smarter load balancing, because it looks like the storage is not used enough. You are too much. The storage is too strong, right? It's too over provisioned. So perhaps use smarter algorithms
Yes.
and cheaper storage. Maybe.
My opinion is cheaper storage. Yes. Is it enough to? However, how can I say that? Actually without this time, the storage overhead is durable to entire systems, and the response time is less than 20 milliseconds, and
So there's a lot of space to use this. There is some space between SLA and what you get.
yes.
Thank you.
Any more questions? Yes.
Is this data available publicly?
Yes, our future plan is to open our FUïTSU, and we have an actual obstacle, three obstacles, and inside our company, and how to open our data to. There are two. Actually, we consider two ways to open data. First one is we manage our data. Other way is to give our data set to such as a storage standard organization. Internally, we have an activity to open to the data. However, I cannot guarantee that when it's open to your data. I have no answer now. Sorry.
Okay, no more questions? Okay, let's thank the speaker once more.